Hello and welcome back to my YouTube channel. In this video, I'll be wiring an Arduino with a push button to toggle an LED from on and off. Now, before we can actually do this, we need to understand some theory first. Okay, so to actually use the push buttons with our microcontroller, we need to once again consult the data sheet. On page 27 of the data sheet, we can see this new register called PIN B. Or rather the pin of the port we'll use. So there'll be a pin B, a pin D, and a pin C. And as you can see, it is our input pin register. So this register keeps track of any input pins. Now, if we recall from one of our previous videos, to set a pin as an input, we must write a 0 to that pin or to that bit in the DDR register. So if I want this first bit to be a 0, an input, I need to write it to a 0. If I want, for example, this bit to be a 0, I need to write it to a 0. And this will set it as an input. Now let's look in detail as to how this pin B register actually works. So here I have 3 registers in theory that we will be manipulating. I have pin D, port D, and DDR-D. And then here I have a basic circuit, or a very simplified one, of what something we might do is. So here we have a switch, external switch obviously, and it's connected to a ground on one side, and on the other side it goes directly into the 0th bit of port D. So everything will correspond to these bits, these final bits, because we are at the 0th one. So we will need to manipulate these bits to work with this. Okay, now what this pin register does is it keeps track of the voltage level here at the pin we are using. So when we set the pin as an input, and remember to do that, we're going to have to write a 1. So let's do that now. We're going to have to, write a 0. So we write a 0 here. We have set it to an input. And now what this pin does is it keeps track of the voltage level here. And internally, this pin, once we do set it as an input, gets connected to this 5 volts. Now this 5 volts lies internally within the Arduino. Okay. So because this pin, or this register, reads in these voltage levels connected here, it has either a 0 or a 1 value. If it's connected, or if it has a high voltage, it will read a 1. If it has a low voltage, it will read a 0. However, there is a problem with this current configuration. If the switch is open, then the voltage here is quite obviously 5 volts. However, let's say we close it. Then there's 2 problems here. If we close this switch, then the actual voltage level here is not entirely clear. Is it going to be 5 volts? Is it going to be ground? Is it going to be 2.5 volts? Is it going to be something in between? That's problem number 1. Problem number 2 is, if we close this switch, we short 5 volts with ground, and this can damage our Arduino. Now to get around this problem, what we can do is use the port D register. So the port D register, as we saw in the previous video, can control output voltages when the pin is set to be an output. However, when the pin is set to be an input like this, what it can do is activate something called a pull-up resistor. So if we write a 1 to the specific bit that has been set as an input in port D, so say this bit, then what this does is it connects an internal resistor to the 5 volts. So we'll get something like this. Now this resistor value is typically between 20 kilo ohms and 50 kilo ohms. However, its actual value is not important for what we are doing. Now let's see what happens if we open and close the pins. The switch. So once again, if the switch is open like this, then the voltage here is obviously 5 volts. So let me write that down. open switch corresponds to high voltage or a 1. So if it's an open switch, then this bit in the pin should be a 1. What happens when it's closed? Well, if it's closed, we'll have 5 volts, but because of Kirchhoff's voltage law, this entire loop, if you will, must sum up to 0. So we have 5 volts, here must also drop 5 volts. So we have 5 drops 5, and so the voltage here will just be 0 volts. If you want to look at it another way, as soon as we close this switch, this is connected directly to ground. And so if we have a closed switch, then we'll get a 0 in pin D. So if we close the switch, this bit will be a 0. Let us make sure we remember this point when we now move over to programming. Okay, so I've just opened up Visual Studio Code and I'm going to move into Platform IO. And I will create a new project. Okay, now I'm going to call this project button, pretty basic. And then I'm going to use an Arduino Uno and I will begin the project. Okay, so I'm going to open up this source code. I'm going to delete it and replace it with this. So I'm going to include all the AVR stuff with this header file. And we will need a delay later on. So I'm going to include delay.h. And actually, before I do my main function, I'm going to define some constants. Now, I want to define the LED pin, or LED, that is the, not the LED pin, the LED. I want it to be 5. This is the onboard LED. And I'm going to specify on port B. And then I'm going to define the button that we will be using. I'm going to use, let's say pin 3 on port D. On port D. And now let me go into my main function. So what I'm going to do is I'm going to set the onboard LED to be an output. And just to make sure it starts as off, I'm going to write a 0 to that specific bit. Okay, and now I should set up my pin. So I'm going to need to set it as an input first. So write a 0 to it. And then I should also activate the pull-up resistor. And so if it's set up as an input, and then I write a 1 to it in port B, as we said, it will activate the pull-up resistor. And now I can go into my main loop. And so what I want to do is have a check here. I want to somehow check if the value of pin B is high or low. Now I want this check to correspond to a button press. And if we recall, when the button is pressed, the bit in pin D goes to a 0. So I want to check here, is pin D, is the third bit in pin D, which is this button, which is where our button is connected to, I want to check if it goes to 0. I want to check that individual bit. And what we can do is this. I can take pin D, and whatever it is, I'm just going to put Y's everywhere. Actually, yeah, Y, whatever it is, it's gonna, that's the 0th, 1st, 2nd, 3rd. And so here is the bit that I want to actually check. I want to check this X bit. How can I check it? Well, I can do this. If I AND it with 1 moved up by button, or if it's easier, 1 moved up by 3 places, what do I get? Well, this is 1, and then I move it up by 3 places, I shift it, the 1 moves up here, right? Because I moved it up by 3 places. 1, 2, 3. So it's there now. And now what happens when we AND it? Let's keep note of the result. Well, here, 0 AND with Y, 0 AND with Y, 0 AND with Y. Well, 0 ANDed with anything. It's just 0. So here we get 0, 0, 0, 0. And then here, what do I have? I have 1 ANDed with X. Well, if the bit was high, or if X is on, then here I get a 1, and once again the rest will be 0. So if it's on, this value is clearly not 0. However, what if it's off? If it's off, we have 1 ANDed with 0, which means this is 0, which means our result is 0. So if we do this and we get a result of 0, it means the button must have been pressed. If we get a result of 1, it means the button, or sorry, not of 1, if we get a result that is not 0, anything else, then it means the button has not been pressed. Because remember, this is technically the value, that's 0, 1, 2, 3, 2 to the power 3, that's 8. So this actually evaluates to 8, but that's not important. The important thing is it's not actually 0. And so this is what we can do. We can say pin D and with 1 moved up to button. And we said this value will evaluate to 0 if the button has been pressed. So I can do that. But there's an even cleaner way of doing it. What you can do is, because in C, anything that is not anything that's not 0 in this statement is true. And so if this is all 0 and then I just not it, then it becomes true. And so what should I do now? So I check if it's 0, and then I can toggle the LED. So I'm going to do port D, toggle it with the XOR operator. And then what should I do? Because it takes some actual time to push the button, let it spring back up, it has some mini vibrations because of the spring, we should delay. And I don't want to be pushing the button too fast, so I'm going to delay for 200 milliseconds. Let me save it. And actually, before I compile, this is a small error. That should be port D. And I just realized there's another problem here. This should be LED, because I want to toggle the LED. If I re-upload it, and then I push the button, it turns on. Push it again, it turns off, turns on, turns off, turns on, turns off. Now that will be all for this video. Thank you all for watching, and I'll see you all in the next one. Bye bye.